So I guess we can get started. So what is today's goal? I think we will try to finish ANOVA. Probably we should be able to finish that. It's not something complicated. Because if you remember what this is, it's just a generalized t-test. So it shouldn't be a big issue for us to finish this one. And we will be doing the regression for 4 classes. And then last week will be just a review. So shouldn't be a big issue for us to finish everything. So just a quick reminder what we have done. I guess it's best to look at the this graph. I recently add this one after yesterday class. So basically what you have is, say, in this particular case is 3 different maybe this is not a best word to use anyway. It's an ANOVA assumption. So basically the idea is that, where's the pen? Where's the pen? Okay. So the idea is you have each population follows a bell curve, right? So there's a bell here, a normal, and there's another bell followed like this one, another one that follow like this one, right? And you want to see if each mean is separate from the other. You want to test whether the alphas are 0 or not, right? And the way you do is actually so do note that the assumption is every bell curve has the same variance. So they share the same, actually, you should see the sigma 1 square is equal to sigma 2 square equal to sigma 3 square because of the way the bell is being drawn, same as the epsilon, right? All the bell curve the same variance, but just different location, okay? And how we actually test this is based on the idea of the measurement of variance, which we covered last time, right? Because this is the data you collect depends on the sampling. You can end up like different shape, right? Need not be the same shape because depend on the sample size also, right? So it can be different shape here. So, but what we're trying to do it is SST, right? If you look at it, it's a measure you use to estimate sample variance, right? It's look at each variable, right? And compare to the overall grand mean, okay? Basically, this is how you would do if you don't have any information of the group, right? You just put all the data together, calculate the mean, and calculate the distance from each data to the grand mean, right? X bar and square it and calculate that. That would be the way we do for the estimate. This is usually S square, right? This is how we estimate usually, right? And now we have grouping information, so we can calculate the variance within each group, right? So that is, you calculate this is SSW, right? So we just focus on each particular group, right? You calculate this, right? For each observation, right? This is, you calculate the SSW, right? And this is another measure of sigma square, right? Finally, you have another measure, right? Which is calculate how the group mean is different from the overall mean, right? And you know 3 of them, SSW plus SSG is SST, right? We know that. So the idea is to compare the variance measure by these 2 numbers, right? And if under X null, right, where mu1 equal to mu2 equal to mu3, in that case, these 2 measures should be same. You cannot say which variance is higher, right? Because both are measuring the variance. And if they're actually different, then it will be captured in SSG, right? SSG looking at how group by group they're different, right? And SSW is within group, right? If the same, then these two SSW, SSG, actually it's MSG and MSW, right? And these two should give you the same measure. But if the groups are different, the MSG will be much bigger, right? Because they're not the same. So you have the difference must coming from more than the sigma, right? To remind you that under now, okay, you expect this thing happen. So just to remind you, should be mu. Okay, so make sure that you understand if the same, everything should, this one should be coincide, right? While this guy remain the same, right? So that is the main idea behind this. Is a one-sided F test. You compare the variance measured by two different measures, right? So that is how we do it in the last time, right? So that's why we calculate the compare MST. There's two different to compare to calculate estimated variance, right? And the between group one, if under the null, these two should give you the same measure, but null doesn't hold. MSG will contain the information that actually there are two are different. So additional is larger. Okay, additional thing comes from the fact that they're not the same, right? So that is the idea. So that's why when we test this hypothesis, we would do a one-tail test. Indeed, it's a right tail, right? Because MSG will be bigger than MSW. Is that clear why this is the case? Is that clear? Because if they're different, right, the MSG will contain the information that the mean are different. Okay? So let's actually see this example in practice, right? So you actually can, from the previous calculation, we calculate was MST, MSG, and MSW, right? And what we're going to do, the F test is MSG, MSW, right? That gives you 2.3. And how you do is you have to draw this, right? This is F. Now, how can you do the F test, right? You have to determine the degree of freedom, and degree of freedom is MSW is between group, okay? MSG, which is C-1, and it's M minus C here, okay? How many columns there? There are 3 columns, so that's actually 2 here. And M minus C, N is 12. 12 minus 3, that is 9. So we're going to check F29. Okay, this F29 here. Okay. And what you want F29 is this number, which we figure out. Okay, is 2.347. Is this going to be bigger than alpha or smaller than alpha? So that's the idea, right? This is just the standard F test. But the fact that it's one-sided because if the null is true, they should be same. If null is not true, okay, then it must be larger, right? So that is the idea. And either you check the p-value, right? Note that it's one-sided, so you don't need to multiply 2, or look at the critical value. Okay, so the p-value, okay, is looking at the right tail area, so just 1 minus f this, right? 2.374, 29 true. Okay, so this is how you would do it, right? So let's actually carry out this process. Open Excel. Okay, I don't know why every time I have to activate again, but okay, just 1 minus f this, 2.347, 29 true. Okay. So it's this number. Okay. So this is how you figure out this area actually is pretty big. So we can't reject at 10%, 5%, or 1%, right? And probably you also want to find the critical value, right? And it should be here, right? If you want to have a 5% here, okay? So we just, the way to do, I think now is to not be difficult. You just F dot inward, oh, sorry. F dot inward. The right hand side is 5%, the left hand is 95. 0.95 and 29. Okay. And the critical value is 4. Right, this value is 4.25. So your 2.34 is less than the critical value. So you can't reject. So we can't say the free group are different. Is that clear? Is that okay? So that is how we got the number here and here, right? So this is how you can test this. Is that a question? Is that a question before? Okay. This is one-way ANOVA. Is that a question? And as I said, it may be good to show the Excel calculation because I want you to understand what we have been doing. Okay. So I actually go to Excel. Quickly, let's spend 5 minutes to show you how we can do this. Okay. I usually save it for the last, but I think now we're going to finish two-way ANOVA anyway today. So I think it should be okay. So what I'm going to do is copy the data here. Okay. And I think it's okay to erase this guy. Okay. What I'm going to do is try to show you, okay, as some of you have expressed the concern of the calculation. So what I do is I just create the data here. I just copy it, and immediately you will see everything can be done in one click, okay, or 2 or 3 click. But you get what I'm saying. So just let me save this file for us. So this is ANOVA. So I'm going to use the Addin. Okay. ANOVA is easiest to not do it from scratch. Okay. So this is data. So what I'm going to do is I will do the data analytic 2-pack. So basically, again, if you have the Mac, then it will be similar, but probably it's there already. So you should use Windows. You go to Options, Add in, and you go and allow you to have the analytic 2-pack. But if your computer has been done, you have been here for the first topic, okay? The first few weeks, we have done the same, okay? The only difference now, we are just going to click on it, okay? And we will choose the very first one, ANOVA single factor, which means one-way ANOVA, okay? As I remember, factor refer to grouping, right? And I said in the beginning, right? The factor means grouping. So one factor approach, okay? So we say, okay, that's very simple. You just tell them the data are grouped by column or row. In our case, it's columns because the data appear in the column. So just tell them what the data there, just a column A to column C. Click OK. And there's a label in the first row. Okay. Return alpha, then done. Okay. So that is the way. I mean, just very simple. I just click what the data is. Is your data a column or row? Do you have the row label in the first row? And output range, and then you're done. Okay. So let's actually do it. Okay. So once I'm done, I click OK. Okay. And actually, you can see it contains everything we want to have, right? So let's actually go one by one and see all the entry there, because that's the goal of this class, is try to make sure you understand every single entry in this table. Okay. So I guess the count should be easy, just number of them. Okay. And sum, the simple, the sum of all the data, right? And average, the simple. Variance is they give, I think the variance they give is the sample variance. So let's see if it's true. Sample variance dot S, and this is data. Okay, so actually they give the sample version. So I think that's fine. Sample variance, and here is the data we have is the SSB 24, right? You can check the slide because the slide is exactly the same number there. Okay, so if you you want to know how you calculate this number, it's actually 24. Maybe I go back to the slide, right? How do you between group is SSG, right? Let's see. The data here we have 24 here. Okay, that's if you don't know how you can get this number, go back to your slide. So every Excel and the slides are actually the same thing here. Okay, and this is SSW 26. Sorry, 6. Right, it's this one. Okay, is the SSW. Okay, so basically this is okay. This number is SSG. Okay, and this number will be SSW, and without doubt you will know this is SST, right? And you should be able to see the three numbers add up, right, by definition. Okay, and you want to know probably what this number, this is C minus 1 degree of freedom, right? Is because you have 3 groups, so number of group is C is 3. Actually it's 3 groups, right? C is 3. Okay, so 3 minus 1, and this one is N minus C. How many in total? N 3 times 4, N is 12. So 12 minus 3 is 9, right? And this is just N minus 1, right? And the next one is this guy, right? This guy is MSG, right? We just 24 divided by 2, right? So you get the column H. And for the column, this one, which is the MSW, okay, which is equal to 46. Maybe I just write down the formula, right? Is the SSW over N minus C here, right? And this is just SSG over C minus 1, right? And what left is this guy, F, right? F would be simply MSG over MSW, right? This is equal to F, right? So it's just 12 over 5.111, right? After that, you calculate the p-value and critical value, okay? The p-value, I think we just shown how to do it, right? Will be just F of this guy, right? 219 true, right? In case you want me to show it, I just show once. Okay, calculate that is 1 minus F dot this. This number, all right? 2, 9, and then true. Okay, so this give you this entry here, right? And the critical value would be the same idea, right? So critical value we just do the same. Okay. Critical value will be just 95%, right? It's just inverse of 95%, right? So is that clear how you get from this diagram? Is that okay? Is that okay? Is that okay? I think it's okay, right? So everything, I don't know why I cannot. Okay, somewhat that's right. Yeah. So any question? Because you should be able to do one ANOVA by yourself now, because every data, but at the end, it is this thing matter, right? This p-value, right? The ultimate, look at this guy. Okay. We do so many things. The last step is look at the p-value, right? If the p-value is less than 5%, as usual, then you're done. You can see the difference. And probably you will ask the next question: what happens if they're different? What do you do the next? Right? That there are many things you can do, but the easiest thing is if you can spot which one has been higher than others, right? Then that is potentially the thing you want to pick. Right? You can do a t-test among any two of them and see if you can say something more. Okay, but this is the first step to do analysis, is try to see if there are difference. Right? So if the group pay make a difference, then you probably want to specialize your strategy to each situation. Right? There's a free group of data. If they're different, then probably you need to investigate further why they're different, how they're different, and that beyond our introductory class. Okay, you can check the textbook for further details, but I don't want to go further. Okay, because of time is very constrained, but and most of you are actually not doing. Usually we don't want to do anything further for this one. I mean, for our purpose. Okay, is that okay? So we just have shown these three groups are different, and that's what you can say. Okay, and if you want particular which two groups different, you have to choose. You have to t-test, right? Then you can do it further. But can you do more? That will be beyond our introductory class. Okay, so the thing we do is we can jointly test that different, and for any specific group, you can do a t-test to tell you which one is actually better than the rest. Okay, and I guess we don't go further than that. Is that okay? If there's no problem, any question? Okay. Oh, by the way, someone actually sent me an email saying what can you bring to the test venue? Of course, I repeat again, is you can bring any physical copy of your notes, no matter how many pages you want to carry. And if you want to use the calculator, use anything that approved in other exam. So any scientific calculator you can bring. Okay. So, but no iPad, no iPhone can be used because of the cheating concern. Okay. But other than that, you can bring no limit to number of pages. Okay. And for your purpose, you want to bring the T table, Z table, F table. Okay. Any question? If no, then we go to two-way ANOVA. Okay. So don't worry, two-way ANOVA will be the same idea. Okay. Exactly, almost the same idea. Okay. The difference is the data. Okay. So to remind yourself what is one-way ANOVA, one-way ANOVA is a look at the group means, okay, and see whether each group means are different from each other, and focus on one type of grouping, right? So each data point, we have one group, right? It's either say in our school, maybe each student will belong to one college, right? And that is one grouping, right? So everyone will have own grouping, but by no means every observation only have one way to group, right? And say in our school, right, beside the college affiliation, you also have your major, right? Whether you're B school, you are social science, you are engineering, right? So the thing is, the question would be if I do two different grouping, okay? And do we see different grouping would have different meaning, right? Say suppose the idea, the data is, let me go to data, it's easier, okay? The data I have is, say, the GPA, right? Or I don't know, time spent on partying or time spent on studying, okay, whatever you like. And each data point will be two grouping. One is the, say, college, right? And the second grouping may be which faculty you belong to or which major you are doing, right? So, so the question would be, okay, in these two grouping, the first question probably will ask is, given this data, can we do one-way ANOVA first, right? Can we say, is college, okay, going to make a difference, right? And or is faculty going to make a difference? Okay, these are two basic questions to ask, right? Let me repeat. Now, instead of the college information, you have faculty information, right? So you can still ask the same question. First, is college going to make a difference? This we have asked in ANOVA, right? But one way ANOVA, and also the same question, right? You can forget about the college, right? Look at simply faculty, right? Is faculty, is it, say, business school have higher GPA than, say, engineering school? Is it true or not? Okay, this kind of question, right? And is it the same, all the faculty have the same GPA or not? Okay, so that is a one question. And then final question that in addition to one-way ANOVA is something interesting is there any what we call interaction effect between two factors? Okay, maybe faculty and college by themselves have no impact. Okay, but okay, maybe people who go to New Asia College have higher GPA for those who just study culture, right? Because of the heritage, right? Or for those who go to the Chongqing College have better GPA for those who do the religious study, right? That is possible, right? So that would be the question we're asking, right? So, or in this application, you can imagine group A may be the location, right? Geographical location where the consumer locate, right? Which district, which area, and B maybe maybe you are the looking at the distribution channel with online offline, right? And maybe there's no difference between online offline or district, but maybe some district, maybe old district, right? Then they would prefer offline, right? Because old people don't use the web surfing, web purchase more often, right? Or the people in the younger district will see the sales more than other district, right? So that it depends on the location, right? And also depends on the distribution channel. So there's a multiplying factor, right? So this is called interaction effect, okay? So we will be more clear later, okay? But just to remind yourself, what we're doing here is instead of one way of grouping, we talk about two-way of grouping, okay? And we try to see these two groupings as a meaningful thing. Why is it important? Because here actually I can have say I have C times of group, right, and R times of group, right, and actually I can have CR number of groups, right, because there were C, say in this case, there's C colleges and R type of faculty, right? I can actually divide them into C types of C times R number of groups and do one way ANOVA, right? And the reason why I don't do this is because there's two things I mentioned, right? One, you cannot look at the interaction effect that I mentioned. Second is if you reduce this to one way ANOVA, you are asking a different question, right? So and very often, right, in medical tests, that is something you do, right? A may be, say, suppose you took a treatment, a medicine consists of two different way of two different treatment, right? A may be having a medicine, first medicine vary his quantity, right? Maybe some chemical treatment, right? And B may be some physical treatment, right? Or another kind of medicine, right? So you can try to combine, mix and match, and see which one is doing better, right? You can imagine the following, right? The easiest thing is a constant argument of coffee, right? And coffee, you can add milk and sugar, right? And A may be different level of milk, B may be different level of sugar, right? But the thing is, there's certain combination of milk and sugar makes the magic, right? So that is the idea. Is that okay? Okay. So in here we have C, as I said, C different group of A and R different group of B, right? And in our discussion, in order to make things manageable, okay, we will have a restriction on the data we have. What we call is equal number of replicates, which means that when we collect data, we make sure that each combination of factors would have same number of observations. Okay, that means that we, in the case of college and faculty, it means that we go to NA college and grab 10 people from business school. We go to CC college and grab 10 people from business school. We go to Saw college, grab 10 people. And we again go to NA college and grab 10 people from engineering. Go to CC college, 10 people from engineering. Okay, each combination have same number of observation. This is not important, but it makes the math and everything much more simple. And in our introductory class, we just fix on those. Okay, even a textbook fix on this. It's not. I make it easier for you to make it simple, but this is what happened with the introductory class. Okay, if you want to know more, it will be beyond the scope of our class. But I hope that's clear. We restrict this one, equal number of replicate. Okay, and Excel only have again, I think the basic Excel Addin only can handle this thing. Okay, so that is also the reason why we focus on that. Is that okay? Okay, so let's look at the data. What we have, the data looks like this. Okay, so before we have only two columns, right? Is each data number and each the group. Okay, and now we have two things. Each data, we have two information. So just remember, maybe this is student one. Okay, student one's GPA. Okay, student one's GPA, right? And this is maybe his college information. For example, this is NA or CC or SAW or UC or so on and so forth, right? And this is his information about the faculty, all right? Maybe business school, maybe engineering, maybe science, right? Maybe art, right? So on and so forth, right? So that is what you have, okay? Each individual, you have to have two kind of grouping. Okay, is that clear what the data is? Okay, and let me remind you that this data, usually in practice, they call long data or narrow data. Okay, because this is usually this is data type you would download from the web. This is the type. Okay, so this is the data that usually you have, and when we discuss our formula, what we usually have is the matrix form, okay, which we will show and in the next slide. And is that okay? Is that okay? So this is usually the data we have when we describe is put in the matrix form. So here looks complicated, okay, but shouldn't be a difficult part. So that's you can see each X have 3 number subscript, okay, 3 number. So the first number represent which group A you're in. Say in our case, which college you are in. Okay, 1 maybe represent NA, I don't know. Okay. Maybe NA, CSE, or so on. Okay, and this is which faculty you are in, right? Maybe number 1 is business school, and so on and so forth. Okay, and the last is the observation number. Okay, which is the you put a serial number to each guy, and for each group you have M prime, because I said we have idea we call equal number of replicate, which means that we have the same number for each combination of faculty and college. Okay, we have M prime for each combination. Okay, so total number of observation will be C times R times prime. Okay, so this is called N. Usually we put N is the total number of observation. Is that okay? So this one is not graphical. So let me make a graphical representation. You will see what we are saying. Okay, so basically it's like this. So A, the columns representing the groupings of based on the say college, right? So in that case, what it's doing is we have college 1, right? In this case, NA, this is CC, whatever, this is SO, right? With different college here. Okay. And you can see this is all the B1, right? The observation. This is say business school. Okay. And so forth until maybe you go to last, maybe engineering. Okay. And that means that all this number, okay, this is all the data from business school for any student, right? And this would be all the information for Saw College and business school student. Okay, so this is a data set. Is that clear? So before, what we have is just column information, okay? But now we have the row, all the rows are grouped together. Is that clear? So this is data that Excel can take, okay? So this one will be the one we'll use it when we input the data in Excel. And how to convert the raw data, this one, if you know how to do R or Python, then you can easily do it. Can you do quickly in Excel? Yes and no. I mean, kind of, you know how to do filter, then you can do it. Just filter and copy and paste and you are done. Okay. Or if you are smart, you can do some VLOOKUP kind of things, you can do it. But I mean, my class is not doing data anyway. So, but for our class, you can just assume the data is in this nice form already. But if you actually do your project, probably you have to handle it in a nice way. But just copy and paste, right? Unless your data is very big. I assume your data will not more than 100, so it's not be an issue, right? Unless you're doing very super big data, that wouldn't be an issue. Okay? Any question? Okay? If no, then we can go further. Okay? Now, all the thing we have is similar to the one-way ANOVA. Okay? Remember the one-way ANOVA, we have what we have, we just to we call what we done in the one-way ANOVA. Okay. In one-way ANOVA, what we have is this diagram, right? So, sorry. The one-way ANOVA, what we have is say, this is group 1, right? X1, right? From the group 1, and this is X2, right? And this is X3, right? They have the same variance, right? And that would be Xi, right? Okay. Okay, this is one way. All of them are the bell curve, each group, right? And the main idea, right, is this is mu1, mu2, and mu3, right? We want to see if all of them are the same, right? So two-way ANOVA is the definition is no different. Okay, we have Xij. Okay, we also have the red color. Now it's not mu1 but mu11, right? It's X11, which means that 11 means is NA New Asia College and B school, right? And you also maybe have something like mu X12, then we have mu12. Okay. And just for simplicity, I just have two number here, X21, right? You have mu21, right? And I also have a X22, then I have a mu22, right? And so on and so forth, right? I also have a X31, right? Mu31, and I have X32, I have mu32. Okay, so everything is the bell, everything has the same variance, although I don't draw it like a same variance, but the assumption is all the bell are the same shapes. Okay, they possibly have different location. The goal is to see if they're in the same location. Okay, is that clear? So that's the model, but this is the setup of that line. So go back to here. It is saying each observation follow a bell, and the bell follow each group. Each group have a specific mean, so it's a bell accordingly. Okay, and now the decomposition is a little bit trickier. Okay, the overall grand mean. Okay, again, mu is basically average of all these things. Okay, overall. Okay, so you can look at the graph, it'll be easy. Okay, so you can see, okay, if you try to combine, okay, if you ignore the data of faculty, right, you just calculate so first put it this way. Okay, suppose you collect all the data, you don't really care about the grouping. So what you have is what we call the big mu. Okay, this big mu comes from the fact that you don't care about any groupings. Okay, just forget about grouping, calculate average. That will be the mean overall mu. Okay, and actually this should be somewhere in the middle because the observation are the same. Okay, and you can also right, this is the mu. Okay, so the decomposition is mu here, Then you can look at factor A. Okay. So the idea is you can also group, okay, these two, okay, together. Okay, you can have merge the faculty information. Okay, and okay, something like this. I don't know how to. This is called x1 dot. Okay, that will be we call mu1 dot or mu1. Okay, and you would do the same for everyone, and this distance we'll call alpha 1. Okay, so basically is you ignore the faculty information, okay, and you would get the alpha. If you ignore the college information, then you will got beta. Okay, and that is how you get the beta. And you also got the final one, remaining one, which is called delta. Okay, and this is how you decompose it. And if you don't want to go to the graph, it's easy to understand what's going on here is this is the overall average, right? And this is the impact from being different college. Okay, and this is impact from being a faculty. Okay, and this one is the impact from particular college times different faculty. Okay, so alpha I is just saying that, okay, if you're in this college, on average, this is the impact on your GPA, right? Maybe this is due to that college have more scholarship or have more library, for example. Okay, and beta J is being the GPA higher if you in that faculty. Maybe that faculty people study more, they had nice day in the lab, whatever. Okay, that would be the beta effect. And the last effect will be you being a particular college and particular faculty that together give you a extra boost. Okay, so that is the idea. But it is just the way you write, you decompose it in different parts. Okay, and this thing we can tell you how to estimate, but that is how you decompose it into different parts, right? Just looking at different parts of the means. Okay, so now I guess it's good to look at the grand sample mean. Okay, and maybe after this I will have break, finish this thing first. Okay, so this is very simple idea. Look at this one. Looks terrible. Okay, but this is saying that just sum over college, right? If I have college faculty, right? Sum over all the college, and then sum over faculty, right? And then next is sum over all student there, right? So basically, look at all the colleges, look at all the faculty, add up all the students, right? So what is this doing, right? If you write more carefully, right, you may run to faculty in each college, right? And then that's how if you in each college faculty combination, That's how you do. All right, just go. But basically, just you go to the data, right? Look at each particular segment, you just sum over it, right? So if you go back to here, it simply means that you just add this thing first, and add this, and add this, and add this, add every single one. Go over. Is that clear what it's doing? Basically, you just disregard any form of grouping. Just calculate this one, right? So the second one is very simple, okay? This one, again, the idea is you are summing over faculty, sum over faculty, right? And this is sum over all students within the same faculty, right? So basically you go from every faculty, each faculty you sum all of them, right? So it's just each faculty, sorry, each college you have a matching, right? Faculty, student in college I, right? Because this is calculate, you give me the college I, then you just sum over all the faculty and look over all the students in that college, right? So if you think it's difficult, just go to here, okay? So what it's actually doing is very simple. It's just simply average of this, the column average. Look at the whole column, the average of this. Is that clear? Just simply adding this whole thing, okay? One column. Okay, the column is the column average. If you look at this table, okay. So basically, this is, if you can imagine, this is the column average. All right, this is overall average. If you try to visualize it, okay, and you can imagine this is what we call the row average, right? So basically, you just fix a college, sorry, fix a faculty, okay, fix a faculty J, and you add all sum over the college, right? So fix a faculty J, you add up NA, CC, whatever college, add up all the student there. Okay, that is what it means, right? Add up all the student there, okay? So it just, if you go back to here, this row, it just, you just take, for example, we just go back to here. It just, I use the color orange, right? We just this whole group. So just average of this thing. Is that clear? This will become the average for the faculty R, right? So that's how you do it. Is that okay? And now I introduce the very last one, which is look at the average for in each particular box. Okay, you want to calculate this box average. Okay, this is what we call X bar 1, 1. Okay, so this is a we call the specific okay. So it's just the last one. Okay, just go into particular group and just sum all the student there. Okay, so this is the idea. Is that okay? So this is the one. Maybe I just clean this one and then show you what is this. Okay. And so overall average will be X bar. And if you do this will be X bar 1 dot. And if you try to do this will be X bar dot 1. And if you try to do this guy, okay, this will be X bar 1 1. Okay, so there are 3 different mean and capturing 3 different things, right? And we would, same as we do when we do ANOVA, we will compare all these means and we try to see the difference between them, look at the variance. We'll give you different measures. And this will do an F-test. We know if indeed they're different. Okay, so that is the main idea there. But before I proceed, let's have a break of 10 minutes. Okay, and then I'll go around to see if you have any question. Yeah. Yeah. So I guess let's continue. So don't worry, it just what's left is bunch of definition of mean and MSG, MSW, those kind of idea, and then you do F test many times. Okay, 3 times. Okay, so this is the mean. Okay, and what we are doing is okay. As I said, this is just estimating the means, but I'm not going to talk about this. It's beyond our scope. Okay. So let us calculate this, and because this is just we have set. Okay. So here we have the data is we have two group of A, two group A and two group B, right? And first, how we calculate this 4.5 is just the same as I said. It just you go to every single data, average of this will give you 4.5. And second is how you get this 3 is from here. Okay, so average of, maybe I just forget about. Okay, this is this number 3. Okay, the second is maybe you want the purple, average of this give you 6. Okay, I think I don't need to go into the detail and show you why the average of this group are the same, but I guess after, if you do this gives you this guy 5. Okay, if you do this I don't know, purple, this gives you 4. Okay, finally, if you want to do I run out of colors, but with the green here, you get the first one. Okay, I think the rest should be intuitive. Okay, that's how you get all the means. Is that clear? So basically, by different grouping, you would forget about it, right? So this means you forget about the grouping number 2, right? There's a dot. That's the dot means. The dot means you forget about the grouping of the second one, right? This one 2 dot means you forget about the grouping of the second grouping. Is that clear how they're defined? Okay. And this later you will see there are different ways to calculate measure the sigma square. So that is how what they are useful for. Is that okay? I think this is just take it to the practice how you apply this thing. Okay, but don't worry, you will never calculate this by hand or by Excel. It's the same as one way. You just click and this comes out. Okay, so you would never actually have a chance to calculate those, but you understand how they comes about, right? Is that okay? If no, then we go next one. Okay, next slide. Okay, and the question we ask is again is the treatment effect based on factor A. In factor A in our case is college, right? It's asking whether college have effect, right? Is it NA or CC or SAW or any other college would have different meaning, right? Or you can look at the faculty, right? Is it B school have higher GPA or higher salary or whatever, right? It would depend on what you're measuring, right? It's the interaction between the both factor will get you the same result, right? Is it going to be, say, if you are medical school, is it going to a particular college will give you an extra edge? Okay, maybe due to alumni effect or whatever effect you can imagine, right? So this is the 3 questions. The first 2 questions will be, I think, is rather straightforward, directly from one way ANOVA, right? Just let us see the grouping, right? The last one a little bit more because we want to check out if the combination has some difference. Okay, is that clear what the question we're asking? Okay, asking the last one a little bit trickier, but the first 2 will be the same. Is that okay? Is that okay? The reason why you want to look at this is maybe say the first question may be asking whether different water make a difference, right? Suppose you are growing a plant, right? The second one may be fertilizer, right? Then adding different amount of sunshine right, will not make a difference probably. And different amount of fertilizer will not make a difference. But some combination of fertilizer and sufficient sunshine then would make the plant grow, right? That would be the interaction, right? Because one may not do the magic, right? Two may not do the magic, but one and two can make the magic. That is what it's doing in the fourth question. And we often would care about this thing a lot because we are thinking about the interaction of the two can create some chemistry, right? That can make a difference. Okay. Is that okay? So I think I have enough motivation for that. So what remains is the same idea. We have to take the variance and decompose it into many parts. Okay. And we have SST, SSA, SSB, and SSAB, and SSE. And turn out the total can be decomposed into 4 different parts. Okay. But let's do one by one here. Okay. Why? So the first one is rather simple, right? The first one is simply you completely ignore the grouping, right? So ignore all groupings, right? You just simply each data subtract from the overall mean, and you go from every college, right? And you go to every faculty, right? And you go for every student, and you just subtract from its mean, yeah, and that's it. Okay, so just simple the way you calculate the variance, right? The numerator, okay? The sum of square total. Is that clear? So very simple, okay? Now, the second one should not be surprising to you. This is just SSG. These two are just SSG, okay? In a one-way ANOVA. The only difference you can see from the question is you just replace. If A, you place the mean for A, right? If you look at B, you look at the group mean for B, right? So you can see the front the same, just adding all the data, right? So you can see the same thing, right? Adding up. It's going through every single student, right? But here, what it's doing is you're looking at the impact of say NA college, right? Colleges, right? So what actually you're doing, let's go back to here. Look at this problem. It's just for each, okay, for the column, okay, what we're going to do is 408330. You just replace this, the first column, by 3 because there's 3 here. And you replace the second column by 6. So that's what you're doing. Okay. You calculate the same thing as you would calculate SST, but you don't use individual value, but you replace all the value by the column average. Is that clear? So let me see. Let's do an example to make it more clear how you calculate this guy. So this is how you calculate SSA. SSA, how you calculate this number. Okay. You're going to do is, let me show the. So all this entry becomes 6. Okay. Why? Because so it becomes 3. So this all entry become 3. Okay. Because this is average of this, and average of this is 6 here. Okay. And how to calculate SSA? You go to this entry 3 and minus the overall mean 4.5. Okay. And you go again to the second one 0 minus 4.5 square, and go on 8 minus 4.5 and so on until you go to the very end of this one. which is 0 minus 4.5. And then you go to the next column, start with 6. Sorry. So it just replace everything by 3, right? So 3 minus 4.5, 3 minus 4.5, 3 minus 4.5. And this is 6 minus 4.5. And then 6 minus 4.5. Okay. And go to the end, also 6, 4.5, because you already replace everything by 6, 6, 6, 6, 6, 6. Okay. So this is how you calculate SSA. Is that clear? So basically, you replace everything by the column sum and do the standard way to do variance, right? And you can imagine how to do SSB, right? You just replace. How you do SSB? You just simply replace everything here by 5. Everything is 5 here. And everything here is going to be 4. Okay. And if you do this, okay, do the variance again, you get 3. Okay. So that's how you get SSB. Is that clear? I mean, don't worry. As I said, you never actually calculate this, but they need to know where, how in principle to calculate. Okay. This is SSB. And how you do the SSAB, okay? And before I do SSAB, I want to, I mean, it's okay, do SSAB. SSAB is a little bit tricky, okay? SSAB is you have to take the, very funny, okay? The way to calculate is you have to calculate the mean within this group minus its row mean minus column mean plus back the grand mean. Okay, so that is something a little bit tedious. Okay, maybe, but I can illustrate in this diagram here. Okay, so how can we do this? Okay, so what we do is we replace this thing by, say, this is 4. So we replace this thing by is the thing within average within inside. So this is replace everything is 6. Sorry, 6 is here. Okay, and sorry, yes. So I have 1, 1, I have 2, 1, 2, 1 is here. Sorry, 6 is here, and 1, 2 is here is all 2. Okay, and here will be all 6 again. Okay, right. So what we need to do is we take this number, say first one, okay, 4. What we're going to do is you have to subtract the column sum, which is 3. Okay, column 3, and subtract the row average, which is 5. Okay, and then add back 4.5. Okay, so the same next is also the 4 minus 3 minus 5 plus 4.5. Okay, it's the same for the second entry. Okay, and same also for the third entry. Okay, but for this entry will be different. This entry will be 6 minus the column sum, which is 6, and minus the row, which is 5 plus 4.5. Okay, square. So this is how you get. So you just take the value average of that particular grouping, smallest group, minus the column average minus the row average plus back the grand overall mean. Okay, it doesn't look very natural, but this is how what we call the SSAB. Okay, and it's a variation due to the two group. Okay, just okay. So it's not entirely clear what it's measuring. We'll try to convince you what it is, but later. But that is what we call the interaction effect. Okay. The last one, SSE, is easy to see because you just take the difference between the observation over the its group mean. So mean within each smallest group. So let's go to here. How you calculate this is just because of the mean of these three is 4, right? This is 6. The mean is 2, and this is 6. So how can you get SSE? Is by looking at the first element, 4 minus 4 square, this one, and then 0 minus 4 square, this one, plus 8 minus 4 square, this guy, and then you go to this guy, will be 5 minus 6 square, and 5 minus 6 again square, plus 8 minus 6 square. Okay, and then also this guy 3 will be 3 minus 2 square, 3 minus 2 square, and then 3 minus 0 minus 2 square, right? Because the 0 is here. Okay, and finally you have 9 minus 6 square, 4 minus 6 square, and then 5 minus 6 square. So add up everything, we give you the SSE. Okay. So that is how you calculate this one. And we don't prove it, but SST is equal to 3 term add together. Okay. So as you expect, SSE is just before we call SSW. Okay. As you would imagine, we actually, how we do F test is, if you want to see whether the college have impact, we want to compare the variance measured by this and compare to this one. Okay. And if this is larger, there must be impact from the college. We compare this to this one. If this is bigger than this guy, there must be impact from faculty. And we compare this to this. If this is bigger, it must be some combination is going to impact. Same idea. Okay. Actually, same as one-way ANOVA, right? One-way ANOVA is comparing within group, between group, within group, right? But there are 3 types of grouping here, right? There's grouping only based on A, grouping based on B, grouping based on A and B, right? So that's how you actually do this. Is that clear what it is? I mean, of course, we will actually tell you the formula, but you can see it's nothing but just this guy. Okay? Is that clear what we are doing? So exactly same as what we do the one-way ANOVA, but because of we have different grouping, we just compare this and this guy, this and this and this, right? Because these are the 3 different versions of SSG, right? Because remember how we do is compare SSG, actually MSG over MSW, right? So you see with MSA, MSB, MSAB, and MSE. Okay, so exactly the same procedure there. Can you see the similarity? Can draw the analog? Okay. So as I said, what you do is divide them by how many of them you're measuring: MSA, MSB, MSAB, and MSE. Okay. Why C minus 1? Because you have C groups, right? And right, C number of college, right? And why is R minus 1? You have R number of faculty, right? And you have interaction factor, because the estimation actually you have to take out the degree of freedom. So this R minus 1, okay? So that is basically is RC minus R minus C, then U plus 1. I'm not going to explain why this is right, but this is the way you can do it. I mean, there's a proof in the slide, but I'm not going to go over there. Okay. And that is the MSE that is divided by this number. Okay. And just to remind you that this is how different way to estimate sigma square. Okay. Just to remind you. Okay. Everything is, all of them are measuring, try to estimate sigma square. Okay. Under the null, they're the same measurement. Okay. This should be the same. But if they have different mean, right, or the treatment effect are different, are not more than 0, they will differ. Is that clear, the model? Okay. So just to remind you, the model we have here is, right, we are trying to see if this is a 0, right, in each question. And the model we have is try to decompose this into 4 different parts. And we are asking the question each part separately. We're asking whether alpha is 0 or beta is 0 or all the taus are zeros. Okay, we do it separately. Okay, so we do, this is the idea. So let's see the calculation practice. Okay, but it just this is division, right? It's R minus 1, C minus 1, R minus 1. I'm not going to go into the detail of this calculation because I think it's trivial. Okay, so I would rather spend time on these 3 particular slides. Okay, and remember, this is same as the one-way ANOVA, right? Because of MSA is asking you discard the grouping, right? You calculate variance, okay, based on just group A, right? So this is, if you careful, you will see this is no different from what we done the first way ANOVA, right? It's the same as this guy, right? The same as one way. We forget about the grouping, right? The same as one way ANOVA, right? Is that clear? The reason why MSE will be same as MSW is because of the fact that if there are no difference between the group I, right? This guy and this guy, they, I mean, the same thing, right? So they cancel out. Okay, that means that same as the MSG. But anyway, so this will be the right tail test. Okay, so that would be the numerator and denominator. Okay, so same as the B will be the same. Okay, it's just the same thing here. Okay, asking whether the impact on the faculty, right? So this does have. Okay, and we can have the same for the interaction. Okay, so I guess this is the most important part for the two-way. Is trying to see if the joining have impact. Okay, so this is the I think it's the most important in this two-way because you will often want to see if their interaction between them are strong. Okay, so I guess it's good to look at this example because we have been focusing on that, and we try to see if A grouping will be meaningful, okay, compared to grouping B. This is two-way ANOVA. Okay, so let's study this carefully, and then we go to the Excel. Okay, so the data we have is this one. Okay, and you can see we calculate MSA is this, MSB, MS baby MSE. Okay. So what you will see is you probably can calculate MS. I want to do the F test for A. So how you do it is you always compare the MSA to MSE, right? So this is, remember what is it? Is this same as MS within MSW? This is MSG, right? So just MSG over MSW, right? This is the same as one-way ANOVA, right? And you calculate the ratio, okay? Of course, some of you ask, okay, if this is smaller than this guy, which is not possible, but in case it's very similar, then you can just go home, right? Because you don't really need to worry about it, right? The grouping actually has no meaning. But of course, the question is, this is 3, is it large enough to say they're different, okay? And unfortunately, it's not, right? Because the idea is like this, right? This is 3. So how many grouping you have? It's just 2, 2 is 1, okay? Because this is C minus 1. This is, remember what this is, RC M prime minus 1, right? So this is 2 times 2 and 3 times 3 minus 1. So it's 8, right? Because R times T times M prime is 3. So 1 8 looks like this, I guess. And what you figure out is 3.7, okay? And what we have is actually 8%, okay? 8%, 0.08. And how can we find this 8%? I just repeat once more. I'm not going to go to Excel. It's just 1 F this, right? 1 8 true. Okay. Where you got the 1? Because you look at A, right? You have 2 columns, so C is 2. Okay. And this case, R is 2 as well. So this is C minus 1. Okay. And how to know it's 8? 8 is just R times C times M prime minus 1. R is 2, right? C is 2. M prime is each element covers at 3 minus 1. Okay. So that's how you get this p-value, which is more than 5%. So you can only say if 10%, then you will okay to reject. If 5% you can't, 1% you can't. Okay. So if you willing to use the 10%, okay, you will say the grouping of A will be different from grouping of A1 and A2 are different. Okay. These 2 grouping will make a difference. Is that clear what we're doing? Is that okay? Okay. So is there any question? So we can do the same for the B and AB. Okay. And I guess it's the easiest. I go into the Excel, okay, because that is something what you need. Okay. So let me do it for the Excel. One way. Okay. Let me do 2-way ANOVA. Okay. It will hopefully it's less boring because I think it's too tedious to. Okay. So the data we have is this guy. Okay. So B1, 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 B2, B2, B2. Okay. We have is 408, 330, and 558, and 9 4, 5. Okay. So these are data with two-way ANOVA. Okay. So the same idea here, we will go to use the data analysis. Okay. We do data analysis, right? And we will call two-way ANOVA with replication. Okay. And you just tell them what's the input range. Okay. And let's see. Do I need the okay. I think they allow you to input the whole thing there. Okay. And then you tell them how many row per sample, because you have actually B1 lasts for 3, right? So that's why enter 3. Okay. And you can say output range. Let's put it here. Okay. Then that is how this one create. Okay, maybe it's just a little bit. Just make sure that you see. So this is the entry for this one in case someone take a picture. So this is just telling them the input range and 3 rows there and 5%. Okay. So here the output is like this one. So this is looking at each B1, right? Looking at this one was A1 sum average variance. I think that is trivial, right? Just looking at each single cell, what is the sum and count, right? So that's why you have 3 here, and this is also the total one. Okay, but I guess we don't need that. But the one ANOVA is something we look at. Okay, so here I guess you can see how the notation is slightly different. Okay, so the question is without doubt, right? This is SS. Maybe use other color. Okay, this is AB. Right. This is E. Right. And I think the sample is just yeah. Okay. So columns, yeah, columns. This is A, this is B. Okay. So slightly different from our definition. I mean, they B.A first. Okay. So that means that this is SSA, right? So this is SSB. Okay. And this is SSA. And this is SSAB. And this is SSE. Okay. So add up the whole column F, then give you the total SST, right? So this is the first thing. Actually, we showed it in our slide. You can check how you arrive each single entry there. Okay. And here we have 2 columns, so column -1, right? Because this is C -1, right? Where C is 2, okay? Because there are 2 columns there, right? And here also the same. You have R -1 and R is 2 here, right? Because from the B1 and B2, right? And interaction, this is just R times C n prime -1, right? R is just oh, sorry. This is sorry. R -1 times C -1, which is 1 times 1, right? And this one last one comes from n will be C R n prime -1. So it's 2 times 2 times 3 minus 1. So it's 8. Okay. And you divide anything from the F column to G column gives you the H column, right? Because you divide everything by degree of freedom or by the denominator, they give you the MS. Right? And how do you get the column I? Right? This is what we just did, right? The MSA over MSE gives you the F, right? And immediately you have 8%. Okay. So this already tells you the answer, right? It's already saying that group A have something, okay, but not very strong. Okay. And if you 10%, you're only okay to say A have some difference. The next is you want to see group B as well. Okay. You want to divide this over this one. Actually, as some of you have seen, MSB is less than MSE. So actually we can go home. We don't need to do anything because by definition, right, you are not going to see anything anyway. Right? So that's why the period is very large. Right? Because of this, suppose if the group have meaning, this will be bigger than this one. But nonetheless, it's not there, so we don't even need to worry about that. Okay. And similarly, we have this over this is too small to say anything. Okay. So I guess by now you know how we can do all of them. Is that clear? So we finished ANOVA, and you can see it's not complicated. Basically, calculator do most of the thing. The only thing I remind you is to understand how to have this Excel understand. Okay, that's the key. Okay, so I see you on Thursday.